Everyone. I've entitled this presentation, Digital Archaeology Solutions for Institutions, Agencies, and Avocational Organizations. So I guess we'll just kind of jump right in. To start, I would like to first acknowledge that Colorado and the Boulder Valley in particular, where I work, is Native American land. It has been home to people for thousands of years. The Boulder Valley most recently was the home of the Arapaho and the Ute tribes. And I'd like to just kind of acknowledge that to begin my presentation. So the purpose of this presentation, as was laid out in the summary, was to give some information about digital solutions that are available to smaller institutions, avocational organizations, and agencies that may have limited budgets for recording cultural resources. As I mentioned in the acknowledgement, the unique environments of Colorado have been home to numerous societies for thousands of years. These societies and the people that comprise them left behind the material remains of their daily lives that we use today in order to better understand the past. As urbanization has expanded across Colorado, especially since the 1950s, these important sites and artifacts are more at risk than ever of being lost and destroyed. In order to preserve important information about the past, I personally believe it is important for avocational organizations, volunteer groups, local governments, and other institutions and agencies to all play a role in documenting cultural resources across Colorado before it is too late. Digital tools utilizing free and low-cost platforms are available that can make this documentation more efficient. I hope to provide some information that can be used by the institutions that I was talking about that have limited access to funds. One thing that I want to emphasize is in the purpose that's listed on this slide, I say to support the documentation of cultural resources across Colorado, providing information on digital options for effectively capturing data. The reason that cultural resources has an asterisk next to it is because something that I want to emphasize is that although I am an archaeologist specifically, and I'll get to that in the next slide more, that I hope that I've structured this in a way so that people can understand and get an overview of the options that are available to do all sorts of different work, from archaeology to museums work, even historical research. I think that these tools could be helpful for that. So a little bit about me. As Erica mentioned, I am the Cultural Resource Program Coordinator for the City of Boulder Department of Open Space and Mountain Parks. And on the left side of the screen, you can see a representation of the land base that makes up that system. As you can see, and as you've probably heard, it kind of surrounds the City of Boulder. It's about 46,000 acres, and there are about 1,800 previously recorded cultural resources on that land. That's, of course, what we know about. The Cultural Resource Program works to make sure that when we do take actions on our land, that we protect the cultural resources that are out there. So I typically do about 10 to 20 projects a year, usually involving a field survey and then, of course, completing OAHP forms and writing reports. Something that level of project, or the number of projects combined with the diversity of resources across our system, makes having a reliable and centralized recording system very important. So I really, when I got the position here at the City of Boulder, I really wanted to go in a digital direction, just really to make my life easier. Now, one thing that I want to emphasize before we really dive through it myself, and I figured that this would be a way to kind of share the experiences that I've had, so it could maybe help someone else who's trying to design a system essentially from the ground up, like I had to. So what I've done here is I've broken this presentation up into broadly defined categories that are based on the types of data that archaeologists collect. Basically, if you're designing a digital system, and as I mentioned before, digital systems can be used to research all sorts of data, or collect all sorts of data, not just archaeological. But in the case of an archaeological system, what you need to do is you need tools that essentially collect images, spatial information, and what I call narrative, qualitative, and quantitative data. That's the stuff that you usually put into forms. You also need to be able to view, organize, and export that data in a digital world. I do again want to emphasize that a lot of the tools I'm showing you can be adapted for a variety of purposes. It's all up to the designer what they want to do. My intent for this presentation is really to review, as I said, I'm not an expert, I don't know everything that's out there. I'm going to be reviewing some of the options that I've come across. I also want to review kind of the things to consider when designing a digital system. And then I will also let you know the routes that I went in designing mine. You don't necessarily have to adopt the same strategies that I did, but I'll let you know what I found out there to be most helpful. So there's a warning that we need to start off with right away. And that is that all of the specific recommendations in here are going to be extremely provisional. And that is because of the nature of, I don't know if you want to call it Silicon Valley, the tech industry, whatever. Many of the solutions that I found and currently use rely on products and services that are operated by companies that may depreciate devices, they may break important functionalities, remove access to a service. This can happen by mistake when you have just outages, but it can be deliberate too. And really it just comes down to company policy a lot, whether or not certain things will be supported. It's just important when you're designing a digital system to realize that the tools that you choose may not always be around. My advice for dealing with these types of dynamics, because at the end of the day, I really do think that the advantages that digital systems present can really be of benefit. So the way to mitigate some of these shortfalls, I think, is to do things like kind of pay vague attention to what the companies that run the services that you're using are doing, who's buying whom, could have implications for whether the service you're using is going to be available in the future. Read the update notes for when you have apps, when you get updates. Read those updates notes, make sure that you understand what's going to be happening with the update, and always have a backup. I think is if you have an app that you really like, have a second one that maybe you don't like as much but does the job. So the first thing I would like to talk about are the options for the various types of tools that are available for collecting data about cultural resources. And this primarily centers around what we commonly know and love today as the quote-unquote smart device, either a phone or a tablet with a touchscreen interface. And in today's world, that means that that device is running either Apple's iOS operating system or Google's Android operating system. We're not going to talk about Windows, I'm sorry. There are other options. Windows can be one of them if you have a nice touchscreen computer. But really the most commonly available options are devices that run Android or iOS. So you're probably wondering what the nerdy Star Trek stuff is about. And what that is that I'm an 80s/90s kid. And I remember a time when, smartphones, tablets, etc. didn't even exist. Heck, laptops didn't even exist by the time I was starting to learn about what was available technology-wise. And for me, watching a show like Star Trek The device that they had in it called the tricorder, which you can see in the screenshot, I thought was really cool. To just have this small device that can capture data from around the environment and tell you about it. And I begged my parents for the toy version, which is in the bottom right-hand corner. And I was sorely disappointed when I received it to find it only had a single LED light and just made sounds. That was kind of boring. But the connection that I want to make is, to me, today's smart devices, I find just as cool as the kid in me found the Star Trek tricorder. There are so many options and things that you can do with it that I just think that the idea of I've got a computer in my pocket is never gonna, that enthusiasm is never gonna wear off for me. So there are advantages to using commonly available smart devices. Most people are familiar with them. When available, a mobile connection can update data on the fly. And if you design your system properly, individuals may be able to even use their own smart devices, minimizing the need to provide equipment. But there's an elephant in the room, and that is the operating system. And I want to start that discussion by talking about this concept of what is known as the walled garden. And that's a term that I believe people started using in the early 2010s or so to describe the way that companies like Apple and Google run their services. They extract value by making sure that you're locked into their ecosystem. So as most people know, you can install an app on Android or you can install an app on iOS. It's not like you can install the same package on both devices. It needs to be different versions. Now, making a choice between Android and iOS is the first thing you have to do, and it's a hard decision. On the one hand, I think that more people are perhaps familiar with iOS, in the United States at least. It has a reputation, at least, of being easy to use. But on the other hand, the Android operating system works in a different way that allows for different capabilities in applications. Essentially, Apple and Google do not, as most know, Apple and Google do not develop all the apps that are on the App Store. Those are developed by independent people. And those developers, they have to play by the rules that are laid down by the App Store that they're seeking to submit to. And one difference between Google and Apple's philosophy is the leeway that is given to developers in comparison. So Apple's system is pretty locked down, and they have their own reasons for that, whereas Google gives more leeway to developers to do things like connect peripheral devices, or show certain notifications, or be able to store files in different places. Google gives application developers more leeway than Apple does. There are also hardware and accessory considerations. Now, this is less important than it used to be, but things like being able, and specifically the idea of being able to connect a USB drive to these devices, until relatively recently, only Android had that capability, but recently iOS does have that capability now, although it is still somewhat more limited than what Android has. But the ability to be able to load data onto a smart device or take data off with a USB drive, that if you choose to go that route, that can be a reliable way of moving data around. The other thing is cost. iOS devices are a premium device. They're generally more expensive, as are the accessories that work with them. Yes, iOS devices are more expensive, whereas Android is quote unquote more open source, and there's a lot more people who are able to make accessories cheaper for those devices. Lastly, there's moving, sharing, and exporting data. Once again, that is more limited on iOS due to the way that it works. Android tends to give more leeway in terms of how you can treat your data, where to move it, copying it, viewing information about your data on the device, etc. So you could probably guess, but the choice that I ended up going with is Android. And I have a list of pros and cons here. For the pros, there are more options to access and share data, both on the device and getting it off of the device. Because of the leeway that application developers are given, I find there's a greater variety of applications available on Android versus iOS. I have to emphasize that that's variety. There may technically be more, in terms of raw numbers, there may be more applications for iOS than Android, but those capabilities are what I'm talking about, that you're able to connect peripheral devices, etc. Android also allows what's called side loading, and that, as I talked about before, you can connect a USB drive to an Android device. Side loading is where you can download an application installer package, move it onto the USB drive, and then onto the device and install it. On iOS, you can only install apps from the App Store with an internet connection. Side loading allows you to install apps without having to go through an app store. Android more commonly has expandable memory and removable batteries. Think like being able to add an SD card or a bigger battery. However, this is becoming less and less common as things move along, and really we're looking at a future where that is probably not going to be a thing for much longer. In general, too, the devices and accessories are cheaper, as I mentioned before. Now there are cons. There are sometimes you can end up with poor quality devices. There are lots of companies out there making Android devices. There's one company out there making Apple devices. So I'll leave it up to you to decide who's more consistent. There's also the issue of what's called fragmentation and how it relates to use life. And what that is that as we just were talking about before, there are a lot of smartphone makers who make Android devices, and they get the code from Google. They end up tweaking it so that it works specifically for the devices that they're producing. Well, that means that when Google updates the Android operating system, then they have to update their version of the Android operating system. And many times companies, and Samsung is notorious about this, will just kind of abandon a device in terms of updates. A device just won't get any updates after a year because they just decided. The last con is that Google's a little bit creepy, depending on your perspective. Just, you know, in terms of how they track people and pay attention to web browsing and stuff like that. That may be something that might make people uncomfortable. On the right is a picture of my personal setup. It consists of two old Galaxy S4 devices, and the upper one, I don't know if it's very obvious, but there's a big crack in the screen. These smartphones are from 2013, and they work really well for my purposes. I should emphasize, I want to emphasize, I got both of these devices. The cracked one is my old phone from around the 2013 era. The one on the bottom is one that I just bought off of eBay. And buying used Android devices is perfectly acceptable, frankly, as long as it's not prone to just randomly shutting down and losing data. For the purposes of using these for a digital recording system, they're great. Although they will one day be made fully obsolete, older devices can have a use life far beyond the normal 1 to 2 years expected of most smart devices today. And that's because, especially on Android, that a lot of the way that the software is being updated, it's less common to see apps just stop working. It still happens, and it will eventually happen, but the amount of time that it takes for that to happen has actually increased, which is pretty nice. The other thing about used devices is, and I must say this is anecdotal, I feel I've noticed an increase in device performance when these devices are not connected to a mobile network or a Wi-Fi network all the time. If you think about it, there's a lot of applications on phones that are always dialing out to sending data and receiving data, even if you're not using the application, and that can kill battery life. However, if you're using these items in the field, if you just put them on airplane mode, I find that they run a lot better. So that's kind of another plug for used devices as an option. So the other set of tools that we have to talk about are the applications. Because a computer, like a smart device, which it is only as useful as the software that it runs. Unlike the Star Trek tricorder, you don't buy a device and it comes with everything you need. You need to find the applications that you need to make it do what you want. Separate applications can create a little bit of a data management headache, but it's a necessary evil. You know, it's just the world we live in until there's a free to download Archaeology app on the Google Play Store. So until that exists, this is what we got to do. Some functionalities can be handled by preloaded apps like the camera, the file browser, etc. But to do anything truly useful, you will need to choose your software carefully. And we're just going to kind of go through a few of the options to make that a little easier. Now, despite all the complaining I did about the whole walled garden thing and Google versus Android and whatnot, there are cross-platform options that for applications that it's the same application, but there's an Android version and there's an iOS version. And I will call those out as I go on in the framework that I've created. But those are available as an option if you would like. So this is what I'm calling my little high horse moment, and that is that I want to emphasize the importance of supporting developers. Many of the applications that I use are maintained by individuals or small companies that provide services that, in my opinion, that are well worth the price they're asking when compared to what else is out there. Because of the models of application distribution practiced by Google and Apple, many developers feel that they have to offer totally unlocked free versions of their software in hopes that you will just buy the paid version because you're nice, and you should be nice. You should buy it. Simply put, we should always make sure that the people who create an application are paid, not only because that will hopefully keep them in business, but also because it's just the right thing to do. Don't be a pirate when it comes to applications. So the first type of application that I want to talk about is the camera application. And it pains me to say it because I have a minor in photography, but we don't need the guy in the picture on most archaeological sites anymore. And that's because the camera applications that are available now, with relatively little training, people can be trained to take really good quality photos. There's less and less need to have, you know, a quote unquote real camera or multiple cameras with you. Things that I like to consider when selecting a camera application are things like viewing image data and basically the options that I have control over. And so when it comes to viewing image data, for those of you that, you know, maybe already work in cultural resources or have in the past, you know that one of the most important things that we do that we have to do when on site and recording is the photo log. And for that, you need to know what the name of the photo file is. And if you don't know that name, it's a little, you can still do it. You can do it by the timestamp or what have you, but it's a little harder to keep track of the photos that you're taking. So I like to look for camera applications where I can take a photo and just like an old school, just like a digital camera, I can take the photo, I can press the play button, see the image I just took, and it'll tell me the file name, and I can write that into my log. Other options you might want to take into account are the ability to adjust image size, quality, and format. That can have implications for just how much data you're storing. Maybe you don't need to be taking every photo at 24 megapixels. Maybe you can downgrade to 12 and still get usable images. Maybe you don't need as high a resolution, or you want to use RAW instead of JPEG. Having those options available can be important. The last thing is manual controls for the camera itself. And while that's going to require a little bit of knowledge of photography, I think it's very helpful because you can do things like you may have a very dark object that you're trying to photograph and there's a very bright background. If you have manual controls, you'll be able to balance the exposure yourself rather than just relying on the camera to decide what it thinks is the best exposure. So my choice, and again, because I'm using Android, is an application called Open Camera. There's no pros and cons list here because it's all pros. For me, it really checks all the boxes. It gives what I think is the highest level of control over factors like how the camera operates, what format to save in, and where on the device to save photos, etc. The screenshot on the left is one that I mocked up last night just to show the different camera controls that are available just in the default view of the app. And you can change, add, or subtract. The one that I want to call attention to, because we were just talking about exposure, is the little box, the second on the left side, second from the bottom. You could use that tool to lighten or darken the image as you're taking it. So I think that this application allows for a fine level of control, and it's my recommendation for a camera app. The next thing we need to consider are our mapping applications, because as we said, we need to collect spatial data. The things to consider, one of the things to consider for that is how simple the interface is. Really, it's going to take anyone a little bit of training to learn how to use a GPS application, especially if they never have before. But the simpler the interface, the better, because that means that people who are learning it can navigate around more easily. Another factor is choosing the most appropriate applications, and that is because, as we discussed before, there are no archaeology recording applications in the App Store. There are a lot of other specialized mapping applications. There are applications for surveying, there are applications for geocaching, hiking, home inspections, etc. And so we're in a position where when you're designing a digital system, you're going to have to find what is not necessarily the right app, but the most appropriate application. And those applications are necessarily going to be designed for something else. In my opinion, the best class of applications that get the closest to what archaeologists do, people who are recording cultural resources in the field, are hiking mapping applications. They have the ability to draw points and name them, and they have the ability to draw lines. And usually you can get away with that. But again, because they're not made specifically for archaeology, you're going to have to use them in a way that is very simple. So I tend to just name my points with exactly what they are. So the site number and feature number, and just rely on that little label that just shows up on the screen for me to tell what it is. Another thing to consider is offline functionality. Some applications, if you lose a mobile signal, you won't see where you are on the map anymore. So you need to choose one that is made to be used in an offline setting. And then lastly, and most important, is the ability to export the data from the app. You need to be able to take the data off, but you'd be surprised how hard it is to do that sometimes. I've listed 2 file formats that I believe, that from what I found, are pretty common. They are .gpx files and KML or KMZ files. Those are common file types that work with a lot of different applications. They work with Google Earth, and you can even import them into a full-fledged GIS software if you need to. But these file formats do a great job with creating line and point data, which is usually what we need. Now, the elephant in the room is going to be GPS accuracy for mapping applications. GPS accuracy depends at least partly on the strength of the received signal. Therefore, the quality of the receiving device can be pretty important. Some smart devices out there don't even have a satellite receiver. So I believe it's the Wi-Fi only iPads, at least they used to not have a GPS receiver in them. So there was no way to actually connect to those satellites. Smart devices are built primarily to be small and portable, as we know. And therefore, having an accurate GPS receiver is not necessarily the priority. I've commonly seen smart devices have an accuracy of anywhere from 10 to 50 feet. That's not great. Now, there are more accurate and, well, actually what I'll talk about actually is on the right is an example of what I'm talking about. You may notice that you can see 1, 2, 3 feature 1s, 2 feature 2s, and a couple feature 3s. That was from a very frustrating day when I realized that my GPS was not working very well. The thing is there are external GPS units, anywhere from a few $100s to several $1,000s that you can buy, that are very accurate. However, and this is important, they're only as accurate as the application you're using. So if the application you're using only records location data to the second decimal place or something like that, it is necessarily not going to be as accurate as something like a Trimble or what have you, because the application itself may have been built to record data in a way that isn't the most accurate. So the picture on the right was actually recorded with a $8,000 to $10,000 GPS receiver that is supposed to be sub-meter accurate, etc. But the thing is I was using an application that didn't process the data in the right way to actually be as accurate as I needed it to. So just remember that is an aspect of this. For this reason, because I'm going to assume that most small governments, if they don't have a lot of money to be, or institutions don't have a lot of money to be going out and recording cultural resources, they probably don't have a lot of money for GPS units either. And for this reason, I personally recommend that GPS applications be used to display data and, maybe guide people to the general location of cultural resources, or just get a general idea of where a cultural resource or a feature on a larger site is. Trying to, as the picture shows, trying to document features that are relatively close together on small to medium sized sites can become problematic. So certainly, as I said, using these applications, it's better to use them on a very basic level rather than assuming that you're going to be able to map a foundation or something like that. So my choice is an application called OruxMaps GP. And that is because it has a very high level of control and customization. I find the data management and export to be pretty easy. It gives you on-screen measurements of angle and distance that I really enjoy, especially during survey. And it has a robust offline maps and imagery support. You can download tiles of imagery in the application itself, so that if you lose a mobile connection, you can just open your saved map and see where you are on the map. There are some cons to it. It is not cross-platform, it is Android only. As I mentioned before, it is not for precision mapping, so the points that I took before were actually made with this application. And as you saw, they weren't super accurate. So yes, definitely not for precision mapping. And it does have a moderately high learning curve. However, I will say that I have personally found it to be worth it. Now, there is a cross-platform option for a mapping application that is very much like OruxMaps. It's called Gaia GPS, and that's the name of it that I have underlined on the slide. It is similar to OruxMaps. It's a little bit simpler. It doesn't have the same level of control over options, exporting data, etc. But that it is a little bit easier to kind of learn. So that is an option if people would like. So up to this point, we've technically been talking about capabilities for capturing images and spatial data that, although the smartphone has made this more secure and convenient, at the end of the day, it's really not that much more advanced than sending someone out with a GPS unit, a camera, and either a form or a notebook. It just isn't. So in terms of what we've gone over so far, we've essentially replaced the camera and the GPS unit. But what about the paper? That's kind of the main thing. And this is where we get a little bit into the conceptual weeds, but I'll try to make it as painless as possible. So the way that I think about it is the data that cultural resource specialists collect is mostly descriptive in nature. And that can include things like measurements, soil types, and other objective observations, or just simply narrative description. Notebooks and paper forms are ideal for collecting data like that because they often provide some sorts of structure to organize the data in discrete ways on the page. And by that, I just mean, a form has different fields. You put different types of information in different areas on the form. In a notebook or on a piece of graph paper, you can create lists, but I think the essential point is that you can organize different types of data discretely. And so by providing either pre-made fields or the freedom to make your own types of entries, blend in where you need to, at the end of the day, the nice thing about paper is there is always somewhere to make a note or put some data or add some data when you need to. You can do it in the margins, you can do it in the fields that you created. Really, it offers you a lot of freedom. So in my mind, in order to be as effective or better than paper, digital recording systems need to be structured but still replicate as much of the potential freedom of writing on paper as they can. And that's a hard balance to strike. Now I'm a nerd and I love spreadsheets. And in my opinion, I think a spreadsheet is the closest thing to a notebook in a digital workspace, because it allows you to freely organize and structure your data discretely while providing additional functions for sorting, filtering, and performing computations. However, I have tried to use the spreadsheet in the field, and it is not a good idea. All the great things that a spreadsheet does, that level of complication, it's great for viewing and working with data on a desktop, not so great. Entering data or trying to view data in the field. And I think what you need is a more simple interface for collecting the data. And so what that is for me are what I call web-based response forms. And so there are two main options available from Microsoft and Google, Microsoft Forms and Google Forms. And the key advantage is that they offer a customizable and simple user interface for collecting data. I mean, these are used by things like community groups to do a sign up for a food drive, or by college students to do surveys, or researchers anyway. You know, they can really be adapted to anything, which is why it's ideal for a digital recording system. Both Microsoft Forms and Google Forms work well on both mobile devices and desktop devices, so that's key. They allow you to create forms with different types of questions and potentially with as many fields as you would like. Now, because I'm in the Google garden, I, of course, went with Google Forms. But Microsoft Forms is a very viable option. For me, the pros to using Google Forms is I found it very easy to learn. The fields are very customizable. Like, again, as you can see in the screenshot, you know, there's a multiple choice option for UTM location. Artifact type is a drop down. The other fields are just open. So it's nice to have that level of customization. Any data that you enter into the form, as soon as you hit that submit button, as long as you're connected to a mobile signal, it'll sync with a cloud-based spreadsheet that is accessible through Google Drive, or otherwise known as Google Sheets. So you can view it later in either that application or on the desktop. The other thing that's really important, and it might be a little bit hard to see, but the screenshot of the spreadsheet that I have, I think it's the third row down, shows what I think is very important, that Google Forms retains formatting. If you write a few sentences and then tab down to start a new paragraph, it'll retain that formatting when it adds it to the spreadsheet. And that's really nice, because then you can just copy that information into your OAHP form or the report that you're working on, or what have you. Another key advantage for me is a really robust ability to roll back changes to your spreadsheet. There is a history view in Google Sheets that sometimes will allow you to roll back changes that were made months ago, cell by cell. So it's nice to have that reliability there. Cons are, it requires an internet connection. There's an asterisk there, we'll get to that. And viewing previously recorded data is only really viable in the spreadsheet. And as I said, working with spreadsheet in the field, not always the most fun. Using, in my case, the Google Sheets app on a phone is a little bit better, still not great. Now, to return to the internet connection issue. Google Forms, yes, runs on a mobile network. You need to have web access in order to use it. There are some additional utilities out there that allow you to move your Google form into basically their setup to create an offline version of it. I use a service called AppSheet, AppSheet, that does that for me. It's fairly complicated, more complicated than just using Google Forms, and that's why I didn't really want to include it in this presentation. But just know that there are options out there for making your Google form accessible offline. So I wanted to kind of talk a little bit about well, it was going to be one principle, but then it turned back into multiples. So crossing out the S, I shouldn't have done that. But some principles for designing your form. In my opinion, the open nature of a platform like Google Forms is a double-edged sword. As I said, you can make as many fields as you want, and you can add them to an infinitely expanding spreadsheet. This can result in a kind of an unwieldy way to collect data. 15 or heck, even 5 attributes may not seem like a lot when you're recording one artifact, but try and do it 10 times in a day. That's really gonna add up and you're gonna get pretty annoyed. So I think a good rule of thumb is to start with a paper form, replicate it in a digital space, then attempt to reduce the number of entries from the paper form by combining fields. As I said before, the Google form does retain formatting. So again, space tabbing down or adding additional information or what have you is pretty easy, and that will be that information you'll be able to see that it is discrete in your spreadsheet when you go to it. As I mentioned before, the data is typically stored, well, actually, I should talk about one thing to do that I learned a couple weeks ago is to not deploy this sort of stuff without extensive testing and training. Just make sure that the form is doing what you want, that the data comes out in the spreadsheet the way you want before you try deploying it in the field. You can get a little bit confused and turned around, but usually it's pretty easy to fix, especially with the history function. The last point is concerning viewing your data. As I mentioned before, the data is typically stored in a single spreadsheet, which, you know, depending on how many entries you have, you could have a spreadsheet with 50 columns, and that's a little bit unwieldy. You can still use filters and whatnot to view the data. So in the screenshots on the left, you see the one behind shows a number of different sites in resource designation, and the image on the image in front shows that that has been sorted to only show the artifacts that are associated with CAD S022. Filtering does help a little bit. However, there's a function called import range. And what that does is it allows you to create a second spreadsheet that is looking at the original master spreadsheet and allows you to pull data from the original spreadsheet over to the other one. That's useful for sorting your data. So you can take, you know, I could take all of my artifacts and use this import range function to put all of my artifacts on one spreadsheet and my features on another and such. The other nice thing about making a second spreadsheet for viewing your data is that any edits made to it will not destroy the original data. In fact, if you are, if you try to edit the spreadsheet that is looking back at the master spreadsheet, if you try to edit one of the cells, everything will actually just disappear. And you just have to undo it, it'll come back. But it's kind of a safeguard against messing up your data. So as I was talking about, the Google Forms and Microsoft Forms, they sync automatically to the cloud. But you still need to get your spatial data and your photos off of the device that you're using, because that information doesn't do any good staying on the device that you recorded on. As I mentioned before, file browsers or USB connections are now an option for iOS. They have been an option for Android. So being able to move your data off of the device can be as easy as plugging in a USB drive. If you do that, you are going to need a file browser application, something essentially like Windows Explorer, which will show you where your folders are, what's in them, etc. It will allow you then to move things out of the folder where you exported from your app onto the USB drive. The other option for getting data off of your device are cloud service providers. And those are things like Dropbox, Google Drive, Microsoft OneDrive, that are pretty integrated, are integrated very well with the operating systems, iOS and Android operating systems. So as long as you can export the data from the application you're using, being it a camera or the mapping application, uploading it using a cloud service provider should not be a problem. So for my choices on data management, for the file browser, I prefer an application called Explore File Manager. As you can see by the screenshot, the things that I like about it are it presents the files and folders in a tree setup, so it's very easy to see what files are in which folder. It also has a two-pane option to where if you want to move something, so in the screenshot there's stuff under the root drive. If you wanted to move it over to the pictures folder, you can look at both folders side by side and move the data, and I find that very helpful. Now, one thing I will say is if you're talking about Android, that there are Android devices usually come with a fairly adequate file browser pre-installed. So an application like this, usually you might not even have to get, you might just be able to use the pre-installed file browser. I just prefer this one over most stock file browsers because it has additional functionality. As far as for cloud services, because I'm in the Google Garden, I went with Google Drive. It's, you know, especially since I'm using an Android device, Google Drive is the native cloud application, so it works more reliably. The other thing that's nice about Google Drive is that it has the Google Office suite, and as we were talking about, that's how you view your spreadsheets, and it's nice to have everything integrated into one. Now, if you go with Microsoft Forms, OneDrive would be the cloud application to use for that. But my choice is Google Drive. So the last thing I want to talk about is processing data, and I didn't have a whole lot of time, so I didn't really want to get into the weeds on this one. But the first thing I want to emphasize is that digital recording systems, unless they've been designed very well, are not a substitute for filling out the OAHP forms. I've given the link to those forms right there. and so it's important that we, even if people are recording this stuff digitally, that it does get reported to the state. Guidelines for submitting data can be found in the Colorado Cultural Resources Survey Manual that is available online. And yeah, that's very important. The other thing that I want to just mention is that Google Earth Pro is a very good option for organizing your spatial data. It can open GPX and KML files. It can even open shape files and export in those formats as well. So using an application like Google Earth to organize and sort your spatial data is very important. And the thing is here is that I know that I'm not really giving you a lot on how to use Google Earth. There are a lot of tutorials out there that can show you how to use it. It's been out for years. And you should definitely check those out. That's kind of beyond the scope of this presentation. But regardless, there is still an issue too of you can't just submit a KML to the state. And so I think for those of you who are maybe not familiar with submitting OAHP forms or submitting location maps, sketch maps, etc., you know, reaching out to organizations like the Colorado Archaeological Society reaching out to contract firms to find I think you'll be able to find archaeologists who would be willing to help teach you how this sort of stuff works. There's also the program for Avocational Archaeological Certification run by OAHP that is very helpful. I would suggest that too. But filling out the forms is the final kind of step of where you're taking all this data and learning how to do that properly, and what the submittal process to the state looks like is very important. And that is the end of my presentation. Yes. So, yeah, I guess I will take a look and see if there's any questions. And there are no questions. So did anyone like to ask a question? Okay. Erica, did you have anything? Oh. Okay, there we go. All right. So we have a question from Suzanne here. Do I typically have a crew with me? I actually have one employee, so no. However, I try to do a lot of I try to do a lot of volunteer work when I can, try to involve volunteers when I can. And so when I design a system like this, I really want to hammer on the simplicity aspect, because especially if you're working with volunteers, that's going to be important to be able to train them up. Let's see, Laura is asking if she wants to know more about archaeological certification. I actually am not super familiar with it. I never went through it, but and Erica, maybe you can jump in here too if you'd like. But as far as I'm aware, it's called the Program for Avocational Archaeological Certification, and it's a program that's run by the Assistant State Archaeologist's Office, and it's a course that you take over the course of, well, when the classes are offered, honestly, and it goes from doing field survey to recording information in the field, and I think that is a really good entry point into learning how to actually submit this information to the state. Oh, and there's Rebecca, so maybe she can say some more.
Hi. This is new. Hi. Yes, so the Program for Avocational Archaeological Certification is ran by our office, but we worked with various land managers and different organizations across the state, including the Colorado Archaeological Society, as well as Christian's Site Stewards Program, and others, to kind of help them develop different programs. You apply through an application on our website, and I can put that to the chat, and Erica then can put it in the chat because I don't think I have that. But you can always contact me, rebecca.simon@state.co.us, and I can talk to you all day about PAC.
She can. Awesome. Let's see. Suzanne also asked, oh, okay. Well, I guess that's in connection to the question about if I go out with a crew or do I record on my own, was the second part of the question. And yes, a lot of the time I do record by myself. Amy has asked, what is my opinion of the iPhone camera? Fine. It's great. It's awesome. Honestly, most smart devices have decent cameras. Like I said, I use 2 devices from 2013. I believe the standard that's in the Colorado Cultural Resource Survey Manual is that photos need to be at least 7 megapixel resolution. I may be wrong on that. Maybe it's 9. But most smartphone cameras available today, you know, iPhones, Androids, etc., are well above that. So I think that's fine. Let's see. Richard, that's a little bit of advice to look for data formats and apps likely to persist for decades. Little that was around 25 years ago in the 1990s is around today. Very true. Simple photo test spreadsheet formats have been around since then, and the backup should be in those formats. And that is a very good point. One thing that I want to emphasize is that the primary reason I went with Google Forms is that it allows me to just store my stuff in a spreadsheet. And a spreadsheet is one of the most simple ways to store data, and you can export it into formats like a CSV that technically should be able to be read forever into the future. So I think that that Richard's comment is very important, that making sure that you do things in a way that you'll be able to continue doing them. And that's another reason why I don't want to dog on the idea of getting old used devices, because the thing is once Apple or Google decide to stop updating them, and if they continue to work, continue using them, really. I mean, especially with an Android device, being able to load applications from a USB drive or something like that, technically I would not have to connect to the Play Store or even log in with a Google account on one of those devices. And so my idea is that for as long as the applications that I'm using still work on that old 2013 version of Android, I'm good. I think in the future I'd like to get a more modern device as my work phone and just use that, because right now I have a work phone, my work iPhone, my personal phone, and then my S4 when I'm out in the field. So that's 3 phones. So if I had just one work iPhone, one work Android phone, that would be better, but you know, budgets. Let's see, are devices owned by government departments? Oh, and this is Scott who asked this question. Are phones and devices owned by the government departments under which archaeology is performed, or are these devices owned by the individuals using them? Just curious how selection of devices works, or if there's a lot of red tape or not over approved and non-approved devices. So that's actually a very good question. I ran into this recently, actually, with working for the city, because technically as a public employee, any work that I do on personal devices could make them requestable under the Colorado Open Records Act. However, you know, cultural resource data is sensitive information that is typically excluded from those types of requests, but you know, I don't want to go to court. So I generally try not to do things on my personal device. Well, technically the S4s that I use are my personal devices, but I don't open my email on them. I don't browse the web or anything like that. If someone really wants to look at them, they can see a bunch of pictures of rust. Now, that I think is specific to me as a public employee. Red tape and whatnot and policies on using devices are going to depend organization to organization. But the thing is, I think that there is great potential in a system like this to do something simple like, hey, volunteers, show up at the site, bring your phones, and I'll just send you the link to the form, and you can just do the form on your own phone. And that's nice to be able to not have to issue equipment and whatnot, especially during in the COVID world where we don't want to be spreading germs. So I think it's going to depend on the particular organization, what they feel is safe and best practices. But building a system that allows people to just kind of jump on it, I think is great for volunteer projects. Let's see, Laura asks, have I heard of ArcGIS's Survey 123 app to record archaeological sites? It's a spatial app that has a form that you can build yourself and also includes pictures. ArcGIS says deployed apps, the App Store. Okay, great. No, I'm the phone app is free, but the ArcGIS subscription costs money. Yeah. So yeah, no, I haven't tried that because, you know, I really tried to go with freely available options at first because it, you know, I actually get to use ArcGIS Collector now at work, which is amazing. I love that application. But you need people who know what they're doing. So like we have our own GIS department. That's very helpful. But yeah, I think ArcGIS is Survey 123. That's a good idea. One thing I do want to throw out there though is when I was designing my collector app alongside the GIS department, originally we were going to go with the design that integrated the pictures into the spatial information. So you could make a point or a line or a polygon and then attach a picture to it. And that's the direction we were going until I realized that in order to get all of that data out, and I'm not sure about ArcGIS or ArcGIS Survey 123, but at least in Collector, I would have to use the ArcGIS application to get all of my data out of it. And so while I was talking before about how simple spreadsheets are and how much I really like that, I didn't love the idea of having to open one of the buggiest and slowest applications on my computer just to get my narrative data out. So when we last met to design the collector app with our RIS department, I actually told them that I didn't want to put photos into it. That sort of functionality, and it's not always the case, but it's something that people might want to check on if they're looking at options like this. Just pay attention to what you're going to have to do to get the data out. For me, it's simpler for it to just upload it to a spreadsheet, and for my photos to just be floating in a folder somewhere that then I can move onto a folder on my computer. But different people have different needs, and yeah, the different options should be considered for sure. So thank you for that. It is a bit cumbersome to extract data from. That is good old Esri. Love them. Any other questions? Okay. Well, with that, I think I am done. I would like to really throw it out there that if anyone has any further questions, you can feel free to email me. My email is driverc@bouldercolorado.gov. I should have put that on the slide, but driverc@bouldercolorado.gov. So you can email me if you have any additional questions. I love talking about this stuff. So like I said, I'm not an expert, but I'll talk all day about it. So thank you to everyone for attending.
Thanks so much for doing this, Christian. We really appreciate it.
Yeah, it's great.
All right. Well, thank you all for attending today. Hopefully we'll see you next week for our webinar on the preservation plan. Hope everyone has a great afternoon.
Goodbye, everyone.
Bye.